everybody, welcome back. So for the beginning of chapter 2, well, we're at a point where we're not actually at the beginning because a lot of you have completed these topics. So you have a few that's remaining to learn over here where you could see the 5%, 11%. Okay, so I like to just use the lowest percentage to go over for starters, okay? So the lowest percent I see in this entire list is the topic where you're finding the future value and interest for an investment earning compound interest. Now, I'm using a program that it might move around and you may see me tilt or something. But I love this program because I can write on the internet in a sense, okay? So let's look at the first question here for finding the future value and interest for an investment earning compound interest. So a bank offers an investment account with an annual interest rate of 1.27% compounded annually. Susan invests $3,500 into the account for 3 years. So we're going to answer these questions below. Now, it's a good idea for you to click on the list of formulas so we can see all of the financial formulas used. The ones you use the most are the first, second, third, and maybe the fourth one. The other ones we don't use that much. And then as always, I like to make sure that you can see the explanation for compound interest. Okay, so we know what formula we're going to use. Then we have to convert the rate to a decimal. And then N is the number of times a year the interest is compounded, which is only one time. And then that is for 3 years. So you can see where you put all of these numbers. Okay. All right. So let's go back to the question. Okay. So the calculator that I'm going to use is my TI-89. I don't know if you can see that. It's an amazing calculator. I love this calculator. I just do. Okay, so now I'm writing on a slant, so it may be a little bit sloppy. Okay, so remember the chart that we made was the initial amount, which is 3,500. Then the rate is going to be the 1.27 divided by 100, which gives us, so 1.27 divided by 100, which gives us the 0.0127. And the N is, it says annual, so annual interest rate. So the N is 1 and the time is for 3 years. So we plug so A is equal to the principal. So A is equal to the principal times 1 plus, oh, why do I forget it already? 1 plus R over N to the NT. So we just plug those numbers in. So 3,500, 1 plus 0.0127 divided by 1, which we don't have to put in the calculator. And then 1 times 3 right here. So when we put that in the calculator, we end up with 3,635.05. All right, and I'll try to type it in here. Sometimes it gives me a problem. 36. Come on, keyboard. I'm gonna show my keyboard. Okay, so 36 0.05. Hi, keyboard. All right. How much interest is earned after 3 years? Well, we just do 3,500. So part B, sorry, this is part A. So part B would be the 36. Oops, I typed 3605 and it's 3635. Okay, I'm gonna fix that. So 3635.05 minus 3,500. And we don't really need a calculator for that. You see that that's $135.05. So let me fix my zero here. Hopefully you caught that while I was typing it. And then this would be $135.05. And let's check it. And it's correct. I'm going to erase all of this so you can, like I said, my program, I still am learning how to use this program. I love it because I can write on the internet. But it always takes me a while to figure out this program. Okay? So I'm going to just click try another, but I'm just going to show the result. Okay, so Lucy received a $2,100 bonus. She decided to invest it in a 2-year certificate of deposit, a CD with an annual interest rate of 1.21% compounded quarterly. All right, so I'm going to click on the explanation. So the only thing that's different here is that the N is 4 years. Okay, remember you can always click on more. All right. Okay. And then you just, how much interest did she earn after you figure out the amount that's in the account after the 2 years. Okay. So now, all right, so moving right along, that one was 11%. So the next one is 37% for circumference of a circle. All right, so the only thing that I would suggest here is to be careful of the wording. So if you have the diameter, then most of the time you have to convert for the area, okay? So you have to be a little bit careful, and then you have to be careful with units as well. All right, so the in this picture, you're given the diameter, okay? So it's a good idea to figure out what the radius would be. Oops. So the radius equals half of the diameter, okay? So if the diameter is 12 feet, then you need to divide by 2, and you get 6 feet. So the radius is 6 feet, okay? We have the list of geometry formulas. Let's see if I can get that to pop up. So we're talking about the circle. So you see there, you see right here, we have the circumference and the area is here. Okay. So just be careful of what everything represents. Okay, so for the exact area, also you have to be careful because the exact means that they want it in terms of pi. So that means that you leave it pi. All right. So for the area of this, the area is going to be pi r squared. Okay. Now you can use that calculator if you like. But I like the Desmos calculator, okay? So you can use the graphing calculator or you can use the Desmos Scientific Calculator. So what you would do is just do 6 squared because you don't need to put pi in here. If you put pi in here, it's going to change it to a decimal. So you see that 6 squared is 36. So this exact area, if it lets me type inside, and then hit the pi symbol. Okay. Now the circumference, you could use the diameter. So it could be, it's 2 pi r. So the circumference could either be 2 pi r or pi d, which is diameter. So you could type in 12 pi. That should go away in a second. I told you my program is amazing, but yeah. All right. So now for the approximate area, you're just going to use the same values, but you're just going to use, you can either use the calculator there, or you could type it in the Desmos calculator. So you can type 36 pi, and you see it's 113.09. Well, it depends on what they want. There we go. Feet, and feet. We'll just see what I got wrong. So it says it's partially correct. I don't care. I don't care about being wrong. Yeah, see, I had to round up, but that's a little messy, because there we go with the program that I don't care for. So to assume that you all would know to put a 0 after that first digit is a little bit suspect. Okay, so we'll just do another one, because that just yeah, that's a lot. That's a lot. And I would assume that most students would miss that. And that's okay. So we know the formulas. So let's just do another one. So we have the radius is 6 millimeters. I'm not going to write the formula down. So you know that the area, the exact area, is going to be it's creating objects in there. I don't know. Again, why I love my program, but it drives me crazy at the same time. So, and it's millimeters, I believe. Oh, wait. Pi r squared. What am I doing? 36 pi squared. And then the exact circumference would be, I think I missed the feet. Did I miss the feet squared on the last one? I may have. Because it's pi r squared. So for the circumference, it would be 2 pi r. So it would be just 12 pi millimeters. So 12 pi millimeters, I believe. And then I'm keep thinking, I'm like, did it catch me when I didn't put the feet squared on there? I don't know. Anyway, so 36 pi, and that's the same thing as before. That's crazy. So anyway, so it's 113.10 millimeters squared, right? And then this one would be the same thing as the other one as well, right? 12 pi, 2 pi r, yes. Did it purposely give me the same exact answers? 37.70, and that would be millimeters. And yeah, it's millimeters, okay. All right, so there's that. Let's do one more. So now we have a diameter of 10 millimeters. So remember, you have to convert the diameter to radius. So that would be 10 millimeters divided by 2. So the radius is equal to 5 millimeters. So the exact area is pi r squared. So that would be 25 pi millimeters squared. And then the exact circumference would be 2 times. Well, you could just do pi d, which is 10 pi millimeters. And then remember the approximate area would just be 25 times pi. That's giving me 78.54. And yes, in the beginning, I missed at the hundreds. I was looking at the 1,000 spot. So just pardon me. Sometimes making these videos is just difficult. And then the other one is just 10 times 3.14, or we're not going to say that. Don't do that. Because we're not accounting for the decimal. So this will be 31.42. So 31.42. And that would be millimeters. It better be right. Alrighty, moving on to the next topic. Okay, so for the next one, we're going to use choosing the best measure to describe data. Okay, so we have a choice between mean, median, and mode. Okay, so when we have 9 members of a fraternity and they have the following test scores, which measure should be used to summarize the data? I would say mean. We want the average. Okay. Each member of the football team was asked to report the year he was born. Which measure gives the most common year of birth? That would be the mode. In a survey, 9 people gave the following ratings for a local politician on a scale of 0 to 100. Which measure should be used to summarize the data? That would be the median. And I better be right. You know how ALEKS is sometimes, likes to trick you. All right, let's do another one. And you can feel free to click on the explanation, okay? So 10 members of the swim team completed the following numbers of laps at today's practice. Which measures should be used to summarize the data? That would be the mean. Miguel wants to determine which letter appears the most often in his favorite poem. That would be the mode, because it appears most often. So when we talk about the mode, we want to see if anything is repeating. Okay. So we want the letter that appears the most often in a favorite poem. Do any of you have a favorite letter? I really have never heard of that. But anyway, a bakery sells 9 types of sandwiches. Here are the calorie amounts. Which measure should be used to summarize the data? I would say the mean, but usually these questions want you to pick one of 3. Summarizing is usually the mean. A little bit confused, but okay. Yeah, see, So I'm going to say the median, because I don't know. To summarize data, we usually use the mean. There's ALEKS again being special. Okay. All right, let's do one more. So a data set shows the age of each resident at Lakeview Retirement Home. Which measure gives the age shared by the most residents? So that would be the mode, because we want the most that appears in the data set. and we're talking about age. A car dealer has used cars for sale for the following amounts. And which, when we talk about summarizing the data, I would say the mean. 9 people gave the following ratings for a local politician on a scale from 0 to 100. That we kind of already answered one like that. So, okay, it's telling me I'm wrong. Okay. A car dealer has used cars for the sale of following amounts to summarize the data. So for B, I'm gonna say the median. I'm telling you right now, the B and C don't quite make sense. So good luck, because I guess the clue for C would be that in a survey, 9 people gave the following ratings for a local politician. So because it's a survey, but I think the other question did the same. So just do enough iterations and it'll start to sink in the pattern of this electronic program. Okay, so these are choosing the best measure to describe data. I do realize that it's a little bit blocked right there. And then when I make the YouTube video, it's probably going to shrink it even more. So hopefully my face is in it.